They told us interstellar objects were just rocks and ice from other star systems. Then 3I Atlas arrived, and it started doing things comets are not supposed to do. A tail pointing toward the sun, an X pattern in space, fragments breaking off at escape velocity. Right now, this object is 270 million kilometers from Earth and closing, and on December 19th, 2025 it will make its closest approach. Every major telescope will be watching, because if this thing does anything unexpected, if it changes course or transmits a signal, we will finally have proof. Subscribe now, because what happens in the next few weeks might rewrite everything we know about our place in the universe. A comet from another star just broke apart in our solar system, and nobody can explain what came out. On November 20th, 2025, 3 amateur astronomers aimed their telescope at something racing past Earth at 200,000 kilometers per hour. What they captured was not supposed to be there. 2 narrow lines shooting sideways from the object, forming a perfect X pattern in space. Not a tail, not dust, something else. The object is called 3I Atlas. It is only the 3rd confirmed visitor from interstellar space in human history. And right now, as you listen to this, it is fragmenting, releasing smaller objects. And the scientific community is quietly losing its mind. Here is the deal. When something arrives from beyond our solar system, we get excited. When it behaves like nothing we have ever seen before, we get curious. But when a Harvard astrophysicist starts suggesting it might be technological, and then the object starts ejecting components, we need to pay attention. This is not science fiction. This is happening right now. And what makes it even stranger is that NASA is watching this thing with more hardware than they have ever aimed at a comet. Hubble, James Webb, the Mars Reconnaissance Orbiter, the Perseverance rover, the Parker Solar Probe, and over a dozen other spacecraft. All pointed at one object. Why? Let me take you back to July 1st, 2025. A telescope in Chile, part of the Atlas survey system, detected a faint dot moving through space. At first, nobody thought much of it. Comets get discovered all the time, but then the computer started doing the math, and the math was wrong. Very wrong. The trajectory was hyperbolic. That means this thing was not orbiting our sun, it was passing through. And when astronomers traced its path backwards, they realized something extraordinary. This object came from another star system, from outside our solar neighborhood, from the vast emptiness between stars where nothing should exist. They named it 3I Atlas. The 3I designation means it is the 3rd interstellar object ever confirmed. The first was Oumuamua in 2017. The second was 2I Borisov in 2019. Both of those visitors were strange, but 3I Atlas is stranger. Think about that for a second. In all of human history, we have only confirmed 3 objects from interstellar space. 3. Out of billions of years of cosmic traffic, we've seen 3 visitors, and this one is doing things the other 2 never did. It gets worse. When NASA officially classified 3I Atlas as a comet in late July, they observed an icy nucleus surrounded by a glowing coma of gas and dust, standard comet behaviour. But then something weird happened. The comet developed an anti-tail, a tail pointing toward the sun. Now, you need to understand why this is bizarre. Comet tails always point away from the sun. Always. The solar wind, the stream of charged particles blasting out from our star, pushes dust and gas away. That is basic physics. That is how comets work. Except 3I Atlas did not get the memo. In July and August of 2025, astronomers watched as this thing sprouted a sunward jet, a beam of material firing directly toward the sun. Not an optical illusion, not a perspective trick, an actual anti-tail defying everything we know about how comets behave. David Jewett, a planetary scientist at UCLA, suggested it might be giant dust particles. Particles about 100 micrometers across. These would be 1,000,000 times more massive than typical comet dust. Maybe, just maybe, these heavy particles were not being pushed by the solar wind like normal dust. Maybe they were following their own trajectory. But that explanation only works if you ignore everything else. Here is where it gets really interesting. Professor Avi Lobe, the chair of astronomy at Harvard, has been following 3I Atlas since day one. Lobe is famous, or infamous depending on who you ask, for suggesting that Oumuamua might have been an alien probe. Most scientists dismissed him, called him sensational, said he was chasing headlines. But Lobe does not care what people think. He cares about data, and the data on 3I Atlas is screaming. Lobe has published a series of scientific essays outlining 8 anomalies about this object. 8 things that should not be happening if this is just a natural comet. And he has created something called the Lobe scale, a ranking system from 0 to 10. 0 means definitely natural, 10 means definitely technological. 3I Atlas scores a 4. Let me walk you through the anomalies. Pay close attention because each one gets stranger than the last. Anomaly number 1. The trajectory. 3I Atlas is travelling along a path that aligns within 5 degrees of the ecliptic plane. The ecliptic is the flat disk where all the planets orbit. It is like a cosmic highway, and this interstellar visitor just happens to be cruising right down the middle of it. The probability of that happening by chance is 0.2%, 1 in 500. Now, you might say, okay, weird coincidence, but hold on, we're just getting started. Anomaly number 2, the anti-tail. We already talked about this, but it is worth repeating. During July and August, this thing was shooting material toward the sun, not away, toward, and it was not a perspective illusion. Multiple observatories confirmed it. A sunward jet that defies the standard model of cometary behaviour. Anomaly number 3, the size and speed combination. 3I Atlas has a nucleus about 1,000,000 times more massive than Oumuamua, and it is also moving faster than both Oumuamua and 2I Borisov. The probability of an interstellar object being this massive and this fast is less than 0.1%. Think about what that means. We've only seen 3 interstellar visitors, and the third one just happens to be both the biggest and the fastest. What are the odds? Anomaly number 4. We will get to that in a minute, but first, let me tell you what happened when this thing got close to Mars. On October 2nd, 2025, 3I Atlas passed within 19 million miles of Mars. That is incredibly close in cosmic terms, and NASA had hardware in the perfect position to observe it. The Mars Reconnaissance Orbiter, equipped with the high-resolution imaging science experiment camera, locked onto the comet. What they captured was stunning and classified. The image shows an X-shaped pattern around the nucleus. Not a single tail, not a double tail, an X. 4 distinct structures radiating outward from the centre. The official NASA line is that this is dust scattering, natural cometary activity. Nothing to see here, but Avi Lobe is not buying it. He points out that the X pattern appeared exactly when 3I Atlas was at its closest approach to Mars, and he asks a simple question. What if the object was releasing subcomponents? What if those lines are not dust trails, but the paths of smaller objects being ejected? And that brings us to November 20th, 2025, the image that changes everything. 3 amateur astronomers, M. Jaeger, G. Riemann, and E. Prosperi, captured a stacked image of 3I Atlas using 20 exposures of 100 seconds each. The field of view was 16.7 arc-minutes across. At the distance of 3I Atlas, that is equivalent to 1.6 million kilometres, and there they were, 2 narrow lines shooting sideways from the object, perpendicular to the sun, creating an X pattern with the tail and anti-tail along the sun axis. Lobe did the math. If these lines represent the trails of smaller objects released near perihelion, when 3I Atlas was closest to the Sun on October 29th, then those objects travelled about 1 million kilometres in 22 days. That corresponds to a speed of 500 metres per second relative to the main body. 500 meters per second. That is escape velocity. That is the speed you need to break free from a parent object and go your own way. Now here is the kicker. There are two possibilities. Either these are chunks of ice breaking off from a natural comet nucleus, or they are small probes being released from a technological mothership. Lobe says we can distinguish between the two by monitoring these components over the coming weeks. Natural ice fragments would behave one way, probes would behave another. If they maneuver, if they change trajectory, if they transmit radio signals, we will know. And NASA is listening. Radio observatories are pointed at 3i Atlas right now, watching, waiting. But wait, there is more. Congresswoman Anna Paulina Luna is working to get the classified high-resolution images from October 2nd released to the scientific community, the ones showing the X pattern at closest approach to Mars. Why are those images classified? What did they see? Let me give you some context. When Oumuamua passed through our solar system in 2017, it also did strange things. It accelerated as it left. Not a lot, but enough to be measurable. And there was no outgassing, no comet activity to explain the acceleration. Lobe suggested it might be a light sail, an artificial structure pushed by sunlight. The scientific community rejected that idea. Then came 2I Borisov in 2019. That one behaved exactly like a comet. It had a tail. It outgassed. It followed predictable physics. Everyone breathed a sigh of relief. See, they said, interstellar objects are just comets and asteroids. Nothing special. And now we have 3i Atlas, and it is doing everything wrong. It has a coma, an outgassing like a comet, but it also has an anti-tail, and an X pattern, and it is releasing components, and it is aligned with the ecliptic, and it is way too big and way too fast for comfort. Lobe has outlined 4 more anomalies, but the scientific papers are still being peer-reviewed. What we know is this. 3i Atlas has an estimated diameter between 440 meters and 5.6 kilometers. That is a huge range because we cannot get a clear look at the nucleus. It is hidden behind all that glowing gas and dust. The comet reached perihelion, its closest point to the Sun, on October 29th at 7:47 a.m. Eastern Time. At that moment it was 1.4 astronomical units from the Sun. That is about 210 million kilometres, just inside the orbit of Mars. At perihelion, the Sun was blasting 3i Atlas with 770 watts per square metre of radiation. That is intense heat. Enough to vaporise ice. Enough to break apart a loosely bound object. And maybe, just maybe, that is exactly what happened. If 3i Atlas is a natural comet held together by weak gravitational forces, the heat at perihelion could have fractured it, broken it into smaller pieces, and those pieces would evaporate faster, creating a brighter plume of gas and dust. Fireworks in space. But if 3i Atlas is something else, if it has any structural integrity beyond ice and rock, then the heat would not break it apart, it would just warm it up. And if it wanted to release smaller components, perihelion would be the perfect time to do it. Maximum chaos. Maximum cover from outgassing. Nobody would notice a few small objects separating in all that cometary activity. Except somebody did notice. The amateur astronomers with their backyard telescopes. And now the world is paying attention. Let me tell you what is happening right now. As of November 23rd, 2025, 3i Atlas is about 326 million kilometres from Earth. It passed behind the Sun in October, which made it impossible to observe from ground telescopes. But it re-emerged in early November, and the observations have resumed. The comet is currently in the constellation Virgo, visible in the pre-dawn sky. If you have a small telescope or even good binoculars, you can see it. A fuzzy white dot moving slowly against the background stars. It will remain observable until spring 2026. And on December 19th, 2025, it will make its closest approach to Earth. 270 million kilometers away. Still incredibly far. No danger to our planet, but close enough for every major telescope on Earth to study it in detail. Here is what NASA is doing. They have mobilized an unprecedented observation campaign. Hubble Space Telescope is tracking it. James Webb Space Telescope is analysing its composition. The Transiting Exoplanet Survey satellite is monitoring its brightness. The Swift satellite is looking for X-ray emissions. The Perseverance rover on Mars took images during the October flyby. The Mars Reconnaissance Orbiter captured high-resolution photos. The MAVEN spacecraft studied how it interacted with the Martian atmosphere. The Europa Clipper, on its way to Jupiter, turned its cameras toward it. The Lucy mission, heading to the Trojan asteroids, observed it. The Psyche spacecraft, travelling to a metal asteroid, looked at it. The Parker Solar Probe, diving through the Sun's corona, is positioned to see it from a unique angle. The Punch mission and the Soho Solar Observatory are watching it pass near the Sun. That is over a dozen spacecraft, plus ground-based telescopes all over the world, all focused on one object. Why this level of attention? Why are we throwing everything we have at 3i Atlas? Because it is the best chance we have ever had to study an interstellar object up close. Oumuamua was discovered on its way out of the solar system. By the time we realised what it was already too far away for detailed observations. 2i Borisov gave us more warning, but it stayed far from Earth. We got some good spectra, some decent images, but nothing like this. 3i Atlas passed within 19 million miles of Mars. That is close. Enough for spacecraft to resolve details, to see structure, to measure composition. And now it is heading toward its closest approach to Earth, giving every telescope on the planet a clear shot. But there is something else, something NASA is not saying out loud. They are preparing for the possibility that this is not natural, that the anomalies are real, that Lobe might be right. Look at the evidence. The European Space Agency is using this event to promote their Comet interceptor mission, a spacecraft designed to launch in 2029 and wait in a parking orbit until a suitable target appears. A pristine comet from the distant Oort cloud. Or, and this is a direct quote from the mission scientist, an interstellar object like 3i Atlas. They are planning to intercept the next one, to send a probe directly to an interstellar visitor, to study it up close, to answer the questions we cannot answer from a distance. And what are those questions? Let me list them. What is 3i Atlas made of? Is it pure ice and rock like a normal comet? Or does it have unusual composition? What is causing the anti-tail? Giant dust particles, magnetic fields, active propulsion. What are those sideways jets, fracture lines, gas vents, ejected objects? Is the X pattern a natural phenomenon or evidence of deliberate structure? And the biggest question of all, where did it come from? We know it came from interstellar space, but which star? Astronomers have traced its trajectory backwards, accounting for the gravity of every planet and the Sun. And the answer is, we do not know. Its path does not point clearly to any nearby star system. It could have been wandering the galaxy for millions of years, or it could have been launched recently and we just cannot trace it back accurately. Lobe points out another anomaly, the rotation period. 3i Atlas rotates once every 16.2 hours. That is relatively fast for an object this size, and the rotation is stable. No wobbling, no tumbling, just a smooth, steady spin. For a natural object, especially one that is outgassing and losing mass, you would expect some instability, some perturbation in the rotation, but 3i Atlas is spinning like a well-balanced wheel. Now, let me address the elephant in the room. Why are we even entertaining the idea that this could be technological? Is not the simplest explanation that it is just a weird comet? Yes, absolutely. The simplest explanation is that 3i Atlas is a natural object with unusual properties. Comets are complex. We do not understand everything about them, and when you have a sample size of 3 interstellar objects, weird stuff is going to happen. But science is not about accepting the simplest explanation. Science is about following the data. and the data on 3i Atlas is bizarre enough to warrant serious investigation, consider this. We live in a galaxy with hundreds of billions of stars. Many of those stars have planets. Some of those planets might harbour intelligent life. If even a tiny fraction of civilizations develop the technology for interstellar travel, or even interstellar probes, then the galaxy should be full of artificial objects. And here is the thing. We would not see them coming. Space is big. Really big. An interstellar probe could pass through our solar system, and we would only detect it if we happened to be looking in the right direction at the right time. Oumuamua was discovered by accident. 2i Borisov was discovered by accident. 3i Atlas was discovered by accident. How many have we missed? How many interstellar visitors pass through undetected every year, every decade, every century? Lobe argues that we need to be more vigilant, that we need better detection systems, that we need to treat every interstellar object as potentially significant until proven otherwise. And he has put his money where his mouth is. The Galileo project, which he founded, is dedicated to searching for evidence of extraterrestrial technology. And 3i Atlas is their first major test case. The project has access to some of the best telescopes in the world. They are collecting photometric data, spectroscopic data, radio data, everything they can get, and they are looking for signatures that would indicate technology. Artificial lights, excess heat from an engine, radio transmissions, course corrections. So far, nothing definitive, but the observations are ongoing, and if 3i Atlas does anything unusual in the coming weeks, we will know. Let me paint a picture of what happens next. Right now, 3i Atlas is moving away from the Sun, heading back toward interstellar space. Its speed is increasing as it escapes the Sun's gravity. By the time it crosses the orbit of Neptune, it will be travelling at the same speed it came in, about 221,000 kilometers per hour, 61 kilometers per second. At that speed, it will take about 20,000 years to travel 1 light year. The nearest star system, Alpha Centauri, is 4.3 light-years away. If 3i Atlas is heading there, it will arrive in 86,000 years. But we do not know where it is going. Its trajectory, when traced forward, does not point to any particular star. It will wander the dark spaces between stars, a cosmic nomad, until it encounters another solar system, or until it collides with something, or until it runs out of volatiles and becomes a dead, dark rock drifting forever. Unless it is not a rock, unless it has a power source, unless it has a mission. Here is a thought experiment. Imagine you're an advanced civilization wanting to explore the galaxy. You cannot send living beings. Interstellar travel takes too long. But you can send probes. Small, durable, intelligent machines designed to visit star systems, gather data, and report back. How would you design such a probe? You would make it look natural. A comet, or asteroid that would not attract attention. You would give it a thick icy shell for radiation shielding and raw materials. You would program it to enter a star system on a trajectory that looks random, not deliberate. And you would have it release smaller subprobes when it gets close to interesting planets. Sound familiar? Now, I'm not saying 3i Atlas is an alien probe. I am saying it behaves like one, and that is worth investigating. The counter-argument is simple. Why would aliens care about us? Why would they send a probe to our solar system? We're not that special, but maybe they are not interested in us. Maybe they are interested in the Sun, or Jupiter, or the Kuiper Belt, or maybe they are just mapping the galaxy, visiting every star system they can reach, collecting data for some vast cosmic census. Or maybe, just maybe, we are seeing the remains of an ancient mission. A probe launched millions of years ago by a civilization that no longer exists. It has been wandering the galaxy ever since, faithfully executing its programming, visiting star after star, long after its creators turned to dust. That is the haunting part. If 3i Atlas is technological, we might never know who made it or why. We might only know that we are not alone. That intelligence exists beyond Earth. That someone, somewhere, at some point in history, reach for the stars, and they made it here. Let me bring this back to the present. The scientific community is divided. Most astronomers think 3I Atlas is a natural comet with unusual properties. A small but vocal minority think it deserves closer scrutiny. And Lobe is standing in the middle asking uncomfortable questions. The criticism of Lobe has been harsh. Some scientists accuse him of sensationalism, of chasing fame, of doing bad science. They point out that extraordinary claims require extraordinary evidence, and so far the evidence for 3I Atlas being technological is circumstantial at best. But Lobe has a response. He says the scientific community has a bias toward conventional explanations, that we're so afraid of being wrong, so afraid of looking foolish, that we dismiss anomalies instead of investigating them. He points out that every major discovery in history was initially met with skepticism, heliocentrism, relativity, quantum mechanics, continental drift, exoplanets. All of these ideas were ridiculed before they were accepted, and the scientists who proposed them were often ostracized. Is Lobe right? Is the scientific establishment too conservative? Or is he just wrong about 3I Atlas? The answer is, we do not know yet. And that is the point. We do not know. And the only way to find out is to keep observing, keep collecting data, keep asking questions. December 19th is coming. The closest approach, every major observatory will be watching. Hubble will take the highest resolution images possible. Webb will analyse the chemical composition in unprecedented detail. Ground-based telescopes will track every movement, and if 3I Atlas does anything unexpected, if it changes course, if it releases more objects, if it transmits a signal, we will be ready. But what if it does nothing? What if it just keeps flying, a boring chunk of ice and rock following the laws of physics exactly as expected? Then we will have learned something valuable. We will have learned that interstellar comets can have anti-tails, that they can develop X-patterns, that they can be big and fast and aligned with the ecliptic, and we will have a better understanding of what natural looks like. But deep down, I think we are all hoping for something more. We are hoping that 3I Atlas is special, that it is the confirmation we have been waiting for, that we are not alone. Because if we are alone, if we are the only intelligence in a galaxy of hundreds of billions of stars, that is a tragedy beyond comprehension. But if we're not alone, if there are others out there, then everything changes. Our place in the cosmos, our understanding of life, our future as a species. 3I Atlas might be the key to answering that question. Or it might just be a comet, a beautiful, mysterious, confusing comet that reminds us how much we still do not know. Either way, it is one hell of a story, and it is happening right now. So keep watching the sky, keep asking questions, and remember that sometimes the most interesting things in the universe are the ones we did not expect to find. The comet from another star is still out there, still moving, still releasing its secrets one anomaly at a time, and we will be watching every step of the way until it disappears back into the cosmic dark from which it came. This is the story of 3I Atlas, the interstellar visitor that refused to follow the rules, and maybe, just maybe, the most important discovery of our lifetimes. But let me take you deeper, because there is a whole layer to this story that most people are not talking about. The political dimension, the institutional resistance, the fight over data. When the high-resolution images from the Mars Reconnaissance Orbiter were taken on October 2nd, they were immediately classified under review. Not classified in the military sense, but held back from public release pending analysis. This is standard procedure for major discoveries. You do not want to release raw data that might be misinterpreted. You want scientists to look at it first, understand what they are seeing, and then present it properly. But here is the problem. Weeks went by, then a month, and the images still were not released. Scientists who wanted to study 3I Atlas were denied access. Even researchers with NASA affiliations could not see the full resolution data. They got low-quality versions, cropped versions, processed versions. Why the delay? According to NASA, it was just bureaucracy. The images needed to be calibrated. The data needed to be validated. Standard procedures take time. But Avi Loeb was not satisfied with that answer. He started asking questions publicly, writing essays, reaching out to colleagues, and eventually he got the attention of Congresswoman Anna Paulina Luna. Luna is not your typical politician. She sits on committees dealing with space policy and national security, and she understands that if there's even a small chance that 3i Atlas is something unusual, the American people deserve to know. Transparency matters. Science cannot happen in the dark. So she started pushing, making calls, asking NASA directly why these images were being held back. And according to Loeb, she is making progress. The images might be released soon, maybe even before December 19th. And when they come out, we'll finally see what the Mars Reconnaissance Orbiter saw at closest approach. What are we expecting to see? Probably more detail on the X pattern, higher resolution views of the coma structure, maybe evidence of discrete fragments separating from the nucleus, or maybe nothing surprising at all, just a comet doing comet things in very high definition. But the fact that it took political intervention to get the data released tells you something about how science works in the 21st century. It is not just about observation and analysis, it is about access, control, narrative. And that brings me to a broader point. We are living in a golden age of astronomy. We have telescopes that can see billions of light years across space. We can detect planets around other stars. We can image black holes. We can listen for radio signals from distant civilizations. But we're also living in an age of information control. Governments and institutions decide what data gets released and when. Private companies own telescopes and satellites, and they decide who gets access. Scientific journals control publication, and they decide what counts as legitimate research. This creates bottlenecks, delays, biases, and sometimes it means important discoveries get buried because they do not fit the accepted narrative. Lobe talks about this constantly. He calls it scientific conservatism, the tendency to reject anything that challenges the mainstream view. And he argues that this conservatism is holding us back, that we are missing opportunities, that we are letting extraordinary objects like 3i Atlas slip through our fingers because we are too afraid to ask bold questions. Is he right? Partially. Science does have a conservative bias. That is actually a feature, not a bug. You do not want scientists jumping to wild conclusions based on limited data. You want skepticism, you want rigour, you want peer review. But there is a line. And when skepticism turns into dismissal, when rigour turns into gatekeeping, when peer review turns into ideological enforcement, then you have problem. The 3i Atlas situation is a perfect example. Most astronomers look at the data and see a comet with unusual properties. Lobe looks at the same data and sees 8 anomalies that warrant investigation. Who is right? They both are. It is a comet with unusual properties, and those unusual properties warrant investigation. These are not contradictory positions, but the way it is playing out in the scientific community, you would think they were enemies. You have astronomers writing papers specifically to debunk Lobe. You have Lobe writing papers to defend his position. You have social media arguments, conference drama, grant committees taking sides, and meanwhile, 3i Atlas is out there, not caring about any of this, just doing whatever it is doing, following physics, following programming, following destiny. Let me tell you about the other interstellar visitors, because context matters. Oumuamua was discovered on October 19th, 2017. It was spotted by the Pan-STARRS telescope in Hawaii. At first, astronomers thought it was a comet. Then they thought it was an asteroid. Then they realised it was tumbling, cigar-shaped, and accelerating for no apparent reason. The acceleration was the key mystery. When an object moves away from the sun, it should slow down. Gravity pulls it back. But Oumuamua was speeding up. Not a lot, just a tiny excess acceleration, but enough to be measurable. Comets do this all the time. Outgassing creates thrust, like a natural rocket engine. But Oumuamua showed no signs of outgassing, no coma, no tail, no gas emissions in any wavelength. It was acting like a comet without looking like a comet. Lobe proposed that it might be a light sail, a thin reflective sheet pushed by sunlight, an artificial structure designed for interstellar travel. The idea was widely ridiculed. Other scientists proposed alternatives. Maybe it was a hydrogen iceberg. Maybe it was a dust bunny. Maybe the acceleration was a measurement error. But none of the alternative explanations really worked. They all required special pleading, unusual compositions, unlikely scenarios, and eventually the scientific community just moved on. Oumuamua left the solar system. We lost our chance to study it, and the mystery remained unsolved. Then came 2I Borisov, discovered on August 30th, 2019 by Gennady Borisov, an amateur astronomer in Crimea. This one was clearly a comet. It had a coma. It had a tail. It outgassed. It behaved exactly as predicted. Scientists were relieved. See, they said, interstellar objects are just normal objects that happen to come from far away. Nothing exotic, nothing strange. Just cosmic debris wandering between stars. And for a while that seemed to be the answer. Oumuamua was an anomaly, a weird one-off, not representative of interstellar objects in general. But now we have 3I Atlas, and it is splitting the difference. It has comet activity like 2I Borisov, but it also has anomalies like Oumuamua. It is both normal and strange, both natural and suspicious. So what does that tell us? It tells us that interstellar objects are diverse, that we cannot make broad generalizations based on a sample size of 3, that every visitor is going to be different, and that we need to study each one individually without preconceptions. Here is something else that bothers me. The timing. 3 interstellar objects in 8 years. That seems like a lot. Before 2017, we had never confirmed any, and now we have 3. Is that because they are becoming more common? No. It is because our detection systems are getting better. We have more telescopes, better cameras, faster computers, automated surveys that scan the entire sky every night looking for anything that moves. The Atlas system that discovered 3I Atlas is designed to detect asteroids that might threaten Earth. It looks for near-Earth objects that could cause damage if they hit us. But in the process, it finds everything else too. Comets, asteroids from the outer solar system, and occasionally visitors from beyond. So the real question is not why are we seeing more interstellar objects. The real question is how many have we missed? How many passed through before we had the technology to spot them? Astronomers have done the math. Based on the discovery rate and the detection capabilities of our telescopes, they estimate that several interstellar objects pass through the inner solar system every year. Most of them are small, most of them are moving fast, and most of them go unnoticed. 3I Atlas is big, about 5 kilometers across. That is huge compared to Oumuamua, which was maybe a few hundred meters, and that size is the only reason we spotted it so far out. Smaller objects would not be visible until they got much closer to the sun, so we are basically fishing in the ocean with a net that only catches the biggest fish. Everything else slips through, and we have no idea what we are missing. That is why missions like Comet Interceptor are so important. We need spacecraft that can respond quickly, that can chase down interstellar visitors and study them up close. Because observation from Earth, even with the best telescopes, has limits. We can measure brightness, we can analyse spectra, we can track trajectories, but we cannot see details, we cannot sample material, we cannot measure magnetic fields or particle emissions or structural properties. Imagine if we had a spacecraft waiting in orbit when 3I Atlas arrived. We could have sent it on an intercept course, flown alongside the comet, taken close-up images, deployed sensors, maybe even landed a probe on the surface. What would we find? If it is natural, we would see ice and rock, craters from micrometeorite impacts, maybe organic molecules, data that would tell us about the composition of material in other star systems. If it is technological, we would see something else. Manufacturing marks, regular geometry, unusual, materials, electromagnetic emissions, something that screams intelligence. But we do not have that capability yet. Comet Interceptor will not launch until 2029, and even then it has to wait for a target. It might be decades before another interstellar object passes through at the right time and the right place for an intercept mission. So for now, we watch from a distance, we collect what data we can, and we hope that 3i Atlas gives us answers before it leaves forever. Let me talk about the public reaction, because this story is not just playing out in scientific journals, it is playing out on social media, in news articles, in YouTube videos, in conversations at dinner tables all over the world. People are fascinated by the idea of interstellar visitors, the notion that something from another star system is passing through our cosmic neighbourhood captures the imagination in a way that normal astronomy does not. And when you add the possibility, however remote, that it might be artificial, that it might be evidence of alien intelligence, the fascination turns into obsession. Lobe has received thousands of messages from people all over the world, some supportive, some critical, some just curious. He shares excerpts in his essays, letters from amateur astronomers, notes from students, comments from fellow scientists. The common thread is a hunger for answers. People want to know, is it natural or artificial? Are we alone or not? What does this mean for humanity? And the honest answer is, we do not know yet. We are still collecting data, still analysing, still debating. Science is a process. It takes time. And in the age of instant information, that patience is hard to come by. But here is what I can tell you. Regardless of whether 3i Atlas is a comet or a probe, its discovery is significant. It tells us that interstellar objects visit regularly, that the galaxy is more connected than we thought, that material from other star systems passes through ours all the time, and if we want to understand the universe, if we want to know what is out there beyond our solar system, we need to study these visitors, every single one, because they are messengers, samples from distant places, windows into alien worlds. 3i Atlas came from somewhere. It formed around another star. It orbited that star for millions or billions of years, and then something happened. Maybe a gravitational interaction with a giant planet, maybe a close encounter with another star, maybe a supernova shockwave. Something kicked it out of its home system and sent it wandering. It travelled through the void between stars, cold, dark, alone, for thousands or millions of years, until it happened to pass close to our sun, close enough for us to see it, close enough to study. And now it is leaving, heading back into the dark, and we will never see it again. That journey is epic, cosmic, humbling. And whether it is a chunk of ice or a piece of alien technology, it deserves our respect and our attention. So as we approach December 19th, as we prepare for closest approach, remember that this is a rare opportunity, a once-in-a-lifetime chance to observe something truly unique. Keep your eyes on the sky, follow the news, read the scientific papers, ask questions, be skeptical, but stay curious. And remember that the universe is full of mysteries. Some of them pass by at 200,000 kilometers per hour, and if we are not paying attention, we will miss them. 3i Atlas is out there right now, glowing faintly in the pre-dawn sky, releasing its secrets, defying our expectations, being exactly what it is, whatever that turns out to be. And we are here, watching, learning, hoping that maybe, just maybe, we are witnessing something that will change everything. This is the most important visitor our solar system has seen in recorded history, and its story is far from over.